Hello, this is John from caveofprogramming.com. In this tutorial we're going to look at constructor parameters in C++ and we're going to take a look at method overloading as well, or at least we're going to get a first look at it. So I've got a Hello World project here which I'm just going to build, and let's just check that it runs. And I'm going to define a new class here. I'm going to right click the project and go to new class, because I thought I'd create a new one rather than using previous tutorials, code from previous tutorials, which is getting a bit confusing. Let's give it one constructor and I'll call it person. Let's imagine that we're modeling a person with this class, so we could be creating an employee database or something like that. And let's give it some private variables. We'll have string name and int age. And I need to include the IOStream header here for string, which, as I mentioned previously, could be different on your platform, and we need using namespace standard. So let's also set values for this in the constructor. So in person.cpp here, let's say that name equals undefined by default and age equals 0 by default. So just to give them some values of some sort to start off with. I also want to give this a method that enables us to see what's in the class. So let's give it a method which I'll call toString, so that can return a string that represents the class's data. And if we go to person.cpp, I can implement that. So let's say string person : toString, and I'll use the string stream class that I showed you in a previous tutorial just to build up some information about this class. And we need to include somewhere the string stream header. Let's just do it here in the CPP file. So include, and we need stream. We've already got a statement saying using namespace standard in person.h, so we probably don't need to repeat it here. We're already using that namespace. Let's write to the string stream persons, well, let's just say name : and we can put ss name and ss. I'll have some punctuation, age, and then let's say ss age, and then finally we can return ss.struct to convert it to a string. And then in the main function here, let's go to here and let's change this C out so that it outputs well, I'll create a person class first. For person, we'll call it person1, and let's output person.toString, person1.toString, I should say. Get rid of this comment here as well because we don't need it. I think that looks good. Let's save that. We've got a little error here, syntax error. I've got a semicolon that I don't need, shouldn't have. Let's just run that and check that it works. So it doesn't work. What did I do wrong? I've got to include the person header as well. So let's do that, include person.h, so using double quotes because it's a header in my actual program rather than being a standard header. And now I think if we save everything and make it build, we've got name undefined, age 0. So one common way of supplying initial parameters to an object is actually to create a constructor that allows you to pass parameters. So what we can do is when we actually instantiate our object, like here, we can pass it the name and the age that we want it to have, which is obviously more useful than having them all kind of predefined, because we can't do much with that. And we could use set methods to achieve what I'm about to show you, but it's just more convenient to do it with a constructor, and it requires less lines of code. Let's go to person.h, and in here I'm going to say, let's create one new constructor. So person and I'm going to say that the constructor takes parameters. Let's start off with just the name, so string name. Now you can actually implement constructors exactly here. In fact, you can do that with any method. This is called like an inline implementation, where you just define the implementation of your method directly here where you already declare the prototype. So let's put opening and closing curly brackets here, and I'll call this new name, actually, new name, because we've already got a name here. We don't want it to conflict. And let's just say that name equals new name. We don't have to do this here. We could define the implementation of the constructor down here, but because we've only got a very small amount of code in the constructor, I'm just choosing to do it here. And all we're doing is assigning name of the person to whatever we pass into the constructor. How do you actually pass that in? Well, let's go back to the main function here. Well, actually, let's just check, see what this says. Age was not initialized in this constructor. Well, that's true, it's not. Also, we've got a missing semicolon there. Well, let's give age, let's just set it equal to 0 here as well. So that's our complete constructor. And now if we go to the main function, let's create another person. Let's say person2. And this time I'm going to put round brackets after the variable name, and in there I'm going to supply a name, which I'll put Bob for that. So the reason we can do this is because we've said there's a constructor here that takes a string as a parameter, a single string. And when C++ compiles this program, it's going to say, for this person1, it's going to say, okay, we need a constructor that takes no parameters. So it looks at the person class and it says, okay, this constructor here takes no parameters. So it's going to run that when it sees this. When it sees this, it's going to say, okay, we need a constructor that takes one string. And it looks in the person class and it says, yeah, okay, this constructor takes one string. Therefore, I'll run this constructor instead of running this constructor. So it's going to pick the constructor depending on the parameters that constructor uses. It's going to pick the right one depending on what you put here or don't put. Let's output person2 as well. So person2.toString. And if I run that, we're going to see, hopefully, that we've got person2 here with name Bob. The age is still 0. We can have as many constructors as we like, as long as they have different parameters. And this business of supplying methods that have the same name, so the constructor, although it's a special kind of method that runs when the object is instantiated, nevertheless it is still just a method, and it also applies to any method, that you can have different versions of that method with the same name, as long as they have different parameters. You can't have two methods with the same name that only differ in the return type. They've got to differ in the parameters, the type, or the number of parameters that they expect. Let's have another one here. Let's say person string new name, let's say, and int age. And for this one, again, I could easily define it here, but just to show you that we're not forced to, I'll create the implementation of this down in the person.cpp. Let's copy the prototype here, go to person.cpp, and I'll put it below this constructor, person : person. Well, I can now just use my paste that in, and we can say name equals new name and age equals, I better rename this new age, really. New age. Okay. And I'll change that also in the header, this new age, because just for consistency, although it probably doesn't actually matter, as long as the type is correct in the prototype. So let's try that one as well. I'll go to my main function and let's just copy this, and now we'll have Sue and 35, and we'll call that person3, and let's have person3.toString. Now if we save that and run it, then we've got another person down here. And this kind of underlines the fact that once you've got your class, you can create as many different objects of that class as you want. You can instantiate it as many times as you want and have different objects, each with their own unique data. So every object gets its own separate copy of whatever data you specify here. This class is purely a blueprint for the different objects that you create. And creating an object is called instantiation. When you create an object from the class, you say we instantiate the class. So like the idea is that the class is like an abstract thing, and instantiating the class, it means kind of making a definite particular version of that class, a particular object, in other words. So again, to practice this, just create your own class and give it, let's say, 3 or even 4 different constructors that can do different things. If you want, you can even put like cout statements in the constructors, so you can see very clearly which one runs. And you only will run one constructor when you instantiate the object, and the particular constructor that you run just depends on the parameters that you've supplied to it. And it's also worth, besides creating multiple constructors, it's worth practicing defining some of them in line like this, just to fix it in your mind that you can indeed define methods here if you want to. You can have inline implementations of your methods, constructors or whatever, actually here in the class file itself. Sometimes you see classes that even have lots of code in the header here and don't even have a CPP file, but or they have a minimal one, but I prefer putting any serious implementation myself in the CPP file, which is a more common way of doing it, and that has the advantage that you can easily just look at the class header file and see what functions are available for you to use, rather than having to trawl through lots of code looking for how the class interacts with the other code in your program. So that's it for this tutorial. I hope you'll try that exercise there, try this for yourself, and until next time, happy coding.